So now let us consider some cases of two plane sheets parallel to each other. Fine. Now I have drawn two plane sheets here with a positive charge density, that is sigma greater than 0 for both the sheets. Fine. Okay. So I would like to find out the electric field at P1, P2 and P3 due to the availability of these two plane sheets. Okay. So now let us consider the electric field at the point P1 in the region 1 towards this side of the sheet 1. Fine. Now as per the rule of electric field, for a positive charge it should be radially outwards for the sheet. These sheets are like this. Okay, and both these sheets have the positive charge. So radially outwards means this way. Fine. So E1 due to sheet 1 radially outwards. E2 also due to sheet 2 radially outwards, neglecting this sheet. So E1, E2 both are in the same direction. Correct? So we have just now learned what is the value of E, that we will substitute and we will find out the total electric field at the point P1. First let us finish the directions. Fine? At P2. Now because the sheet is like this, radially outwards towards P2, E1, direction of E1, let me put an arrow here, that is direction, and direction of E2, as you can see, are opposite to each other, where at the point P2 in the region 2. Let me go to region 3. For the point P1, using the same rule, holding these sheets like this, both are positive. For E1, from E1 towards the P, E1's direction is this side. E2 direction also, electric field is this side. So the directions of E1 and E2 are same at the point P3. So E1 and E2 same this side of the sheet direction, E1 and E2 opposite direction in the center of the sheets, and E1 and E2 again in the same direction towards one side of the sheet 2. These are the directions. Correct? All or these two sheets have sigma greater than 0. Value is same for both. So let us write the value of electric field in the region 1 equal to E1 plus E2. They are in the same direction. So we add the value, that is sigma upon 2 epsilon naught learned just now, plus sigma upon 2 epsilon naught learned just now for both of them, because the surface charge density is same for both of them. So E1 for the region 1 is equal to half plus half 1. So we get sigma upon epsilon naught for region 1. This is a board question. Similarly, as you can see, for the region 2, the electric field E1 and E2 are in opposite direction. So what should I do? I must subtract the values. I write it as addition only by superposition, but when I write its scalar part, I have to subtract. Sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught. My answer E2 is equal to 0 for the region 2. Similarly, for region 3, E3, I can see E1 and E2 are in same direction as for region 1. So directly I can write sigma upon epsilon naught. Calculation is same as done for E1. Fine. So this you can remember it as a learning also. There is no need of thinking. Just learn it from here that if two sheets are parallel and if both the sheets are having sigma greater than 0, charges are positive, then central region electric field is 0. Both the sides the electric field is sigma upon epsilon naught. Fine. Now let us move to the section 2, where both the surface charge density for both the sheets is sigma less than 0, means both are negative. Again we shall find out the electric fields direction at P1, P2 and P3. Fine, using the same method. Now for negative sheet, these two sheets are again parallel to each other, both are negative. So for negative sheets, we have to follow the rule electric field direction radially inwards from the point. So E1, E2. Fine, both radially inwards, same direction you can see. For P2, the electric field as can be seen for the two sheets radially inwards from P2, radially inwards from P2. Okay, so radially inwards from P2, E1, radially inwards from P2, E2 from the point. So here you can see E1 and E2 are opposite to each other. For the point P3, radially inwards from the till the sheet E1 and E2 from the point. Because they are negative, we are going inwards, that side positive, so we went outwards. For the electric field, that rule is known to you. Now similarly, just like section 1, we will calculate the electric field for all the three, understanding their directions from here. Fine. So what is E1? Region 1, electric field for the region 1, E1 plus E2, both are in the same direction. So the value is sigma upon epsilon naught 2 epsilon naught plus sigma upon 2 epsilon naught, which is equal to E1 is equal to sigma upon epsilon naught. Here you can see E1 and E2 are in opposite direction. So E2 is equal to 0 because E1 and E2 are in opposite direction and their magnitude is the same, sigma upon 2 epsilon naught. Similarly, E3 value, magnitude is the same and we have added them. So as in the previous section, E3 magnitude is sigma upon epsilon naught. How? We added sigma upon 2 epsilon naught. Sigma upon 2 epsilon naught is equal to sigma upon epsilon naught. So for the region 1, electric field is sigma upon epsilon naught. For the central region, region 2, E2 is 0. For the region 3, electric field is equal to sigma upon epsilon naught. Correct? This is provided when both the sheets are of same sigma in their value less than 0 or greater than 0 surface charge density. Fine. Now let us move to the third part or the third method in which we have taken one sheet positively charged, one sheet negatively charged. Let us do the same exercise as we did for part 1, part 2. Now we have come to part 3. Now in part 3, P1. Again with the same rule, positive sheet radially outwards, negative sheet radially inwards towards the sheet. That should be the direction of the electric field. Okay. So at the point P1, radially outwards, E1. At the point P1, due to sheet 2, radially inwards, E2. Now you can see what has happened. E1 and E2 are in opposite direction for region 1. For P2, region 2, this radially outwards, E1, radially inwards, E2. See, you can see they are in same direction, radially inwards. Fine? E2. Okay, so this have to be taken care of. E1, E2, both are in the same direction. From sheet 1 going outwards towards sheet 2 going inwards because it is negative. So you can see E1 and E2 are in same direction for the point P2 in the region 2. Now in the region 3, due to sheet 1, as per the rule, radially outwards. And for E2, due to the sheet 2, radially inwards at the point P3 in the region 3. So you can see E1 and E2 are in opposite direction. So automatically we can write as per the previous section, E1 is equal to E1 plus E2 because E1 and E2 are opposite. Magnitude of E1 in the region 1 is equal to 0. E2, region 2, electric field in region 2 is equal to E1 plus E2, which is having same magnitude, same direction, so we add them up and we get E2 is equal to sigma upon epsilon naught for the central region. Similarly, E3 magnitude is equal to 0 because E1 and E2 are in opposite direction for the region 3 point P3. Clear? So if both the sheets are of opposite polarity, this is sigma greater than 0, this is sigma less than 0. Then the central portion has electric field. How much? E2 is equal to sigma upon epsilon naught. The first region electric field is 0. The third region electric field is 0. Clear? So I have showed you 3 possibilities of parallel sheets with their electric field in region 1, 2 and 3. There is no other variety possible for parallel sheets, electric field. So remember this as a memory. Make your own numericals. I have made them and understand the variety. The doubts will come. If both are positive, if both are negative, one positive, one negative, what to do? This is what you have to do. So I hope you have understood. I will just move. You take a screenshot of what we have done and understand and learn whatever is being shown on the board.